In this video, we present Diesel, a tool to blend formulation and processing of hand-drawn data series query. Data series refers to an ordered sequence of data points and are used in multiple fields including finance, astrophysics and medicine. Here, we show a data series of electrocardiograph which we have loaded into Diesel. Electrocardiograph, or ECG for short, is used by physicians to detect abnormalities in their patient's heartbeat. In the data series query, we aim to find matching patterns with a user's sketch efficiently in a large database. This is done by first indexing the database for efficient retrieval. While there exists indexing approaches for predefined subsequence queries, Diesel is the first of its kind to index data series for hand-drawn query, by matching based on pattern rather than absolute value. There also exists a new query approach which was able to process hand-drawn sketches. However, no indexing was performed and it was unable to load the large volume of data we are working on, to that system. In this example, we have indexed 750 series of ECG data containing a total of 75 million data points. Through Diesel, physicians can easily query for irregularities in a patient's ECG with a simple sketch. For instance, the user wishes to query for areas where the P wave, which is a small bump before the peak, is missing. As the user begins to sketch, Diesel will blend the query formulation with processing time. On the back end, Diesel will start filtering potential matches before the query is complete via the index built. Now that the user has finished his sketch, Diesel will finalize the query and return all matches. The matches are shown in the results panel where the user can view all the data subsequences that bears similarity to the sketch. Each row is a match with the query where the first column refers to the series containing the desired pattern. This query took 4.9 seconds and returned 516 matches. After which, the user can click on Show to visualize the selected match from the dataset panel. Here, we observe that Diesel has successfully found a match where the P wave is missing from the pulse. We also realize that this matching pulse is shorter than the other regular pulses. Diesel is able to match this subsequence due to the scale-free nature of the query. Suppose we have used other subsequence query approaches that are based on Euclidean distance, this result would not have appeared. We show another example where the physician would like to find areas where there exists an additional wave between pulses. Such patterns could be a starting point for the physician to search for more abnormalities. The query was formulated and processed similarly. For this query, there are 34 matches and the processing time after the query is complete, is significantly shorter at 246 milliseconds, due to having less matches. We visualize a match again by clicking on Show. The physician can now observe the area where we see more irregularities in the pulses. We have demonstrated Diesel's ability to query subsequences from a large database using hand-drawn sketches. This enables non-programmers to query the database quickly, and efficiently.